Okay, so we are going to work on notes number 11, division of rational numbers. So we already know how to divide whole numbers. We already know how to divide integers. And now we're going to review how to divide fractions and decimals. Geez, nice. Okay, and this is lesson 2-6. I've been struggling with finding a pen, the best pen for taking notes with. And seems like my best one has disappeared. So we're going to make do with what we have. So just to reiterate, when we're talking about two values, if we have same signs, we get a positive answer. So again, when it comes to multiplication and division, what the signs tell us is what kind of sign we get in the answer. And if we have different signs, we get a negative answer. And we talked about yesterday if we have an odd number of negatives. So this is when we have a chain problem. For every 2 negatives, we'll get a positive. And then if there's an odd one out, that makes the answer negative. And if we have an even number of negatives, the negatives will pair up, making positives. So that gives us a positive answer. Okay, so that's a recap from yesterday. So again, the basic rules for multiplying integers is the same as dividing integers. Okay, so before we can talk about how to divide fractions, we need to talk about a property called the inverse property multiplication. Oops, way too many of those. Which basically says multiplying a number by its inverse we'll call it multiplicative inverse always equals 1. So a multiplicative inverse does not deal with the notion of positive or negative, because whatever sign your number has, you're going to get that. So let's talk about one of the words that shows up there, and that's that word multiplicative inverse. And a multiplicative inverse, or let's say inverses. And that's going to give us 2 rational numbers, so anything that can be written as a ratio, whose product is 1. Now, the interesting thing is, this is its birth certificate name, and its nickname is Reciprocal. Okay, and the whole notion behind doing a reciprocal is to figure out how we deal with division. So with fractions, we actually don't divide. We end up multiplying. What do we multiply by? We multiply by the inverse. Okay? So let's talk about an example that a and 1 over a, and we have a stipulation, a can't equal 0. These are called multiplicative inverses or reciprocals. Okay, so remember stipulation, the reason why we can't have 0 in a denominator is because you can't divide by 0. So any number and its reciprocal are called multiplicative inverses. Okay, so let's just practice that skill for a moment. Let's go over to the next page, and the directions would say, find the reciprocal. And you're going to be given an original problem, and you're going to write its inverse. Okay, and that's it. So original problem equals answer. If you have a -5, remember that it means the same thing as -5 over 1. Now we're ready to do the inverse, and it would be -1 over 5. Now what I like to do, because the negative sign has 3 spots it can go in the numerator, it can go in the denominator, or it could go opposite the fraction bar. The best, safest place to put it is in the numerator. We tend not to see it in the denominator, and sometimes when we write it across from the fraction bar, it ends up looking like a big, huge, long fraction bar. So try to avoid that. All right, let's do one with decimals. So we've got 8/10. So what we're going to do is rewrite it as a rational number, which means we're going to write it as the ratio of 2 integers. And another way of changing a decimal into a fraction is just to read it. 8 would be your numerator, and the place value column tenths is the denominator. Now, this is the one and only one time when you're asked to give me its reciprocal, even if you can, do not reduce. So I'm going to write you a little note here. Don't reduce. So that's the one time you don't reduce on a fraction. Okay? So let's review how we deal with multiplying fractions, or dividing fractions, sorry. So what you're going to do is multiply the first fraction by the reciprocal of the second fraction. And remember to reduce answer to lowest terms. Now remember, when you rewrite the division problem as a multiplication problem, once it's written as a multiplication problem, try to cross-cancel, try to reduce the fractions first, then do the multiplication. Just as a reminder, you may have heard your teacher in 6th or 7th grade use this idea. Keep, that's the first fraction, stays the same. Change, that's the operation, goes from division to multiplication. And flip, that's the reciprocal of the second fraction. So let me add a little thing here. So keep the first fraction. So we don't touch him. Change division to multiplication. Flip the second fraction, which again is a kind of a crass way of saying reciprocal. All right, I'm going to flip to the next page, speaking of flipping, and let's talk about how you divide decimals. So this is kind of, I have to write out several steps because there's several things you have to pay attention to. Okay, first off, let's remember this. When you're given a problem, and I'm just going to do with whole numbers, 123 divided by 45, the 123 goes underneath the division symbol, the 45 goes outside. Now, the answer that we get here, bink, bink, we're going to name all of these. So number 1, this guy is the dividend. And how I remember him, when I divide, it'll be the end of him. Okay, so he's the guy that we're not going to see anymore. It's going to go bye-bye. And then this guy, he is the divisor. He is the supervisor of division, the guy in charge. So he's the one calling all the shots. And then last but not least, the answer to a division problem is called a quotient. Now what we do not have when we do long division anymore is we don't write that, if there's a remainder, we don't write R and write the remainder number. We put in a decimal point, we continue dividing. Okay? So let's talk about our steps. So when we're dividing decimals, number 1, we need to make sure that we get the problem set up properly. So the number that comes in front of the division symbol goes under the division house, so to speak. The number that comes after the division symbol goes in front of the house. He's the divisor. Now, number 1, you can't divide by a decimal. In other words, no decimals in the divisor. Okay. So what you're going to have to do is figure out how to make the divisor a whole number. So you're going to move the decimal point right until the divisor is a whole number. Okay, but you are not going to treat one part of your division problem differently than another, so we're going to have to replicate that move with the dividend. So we're going to move the decimal in the dividend the same number of places it moved in the divisor. So think about it this way. If I had one digit after the decimal point in the divisor, if I multiply that guy by 10, now I would have no digits after the decimal. But if I multiply the divisor by 10, I'm going to have to multiply the dividend by 10, which just simply moves the decimal point to the right one spot. Okay? So, now we've got a problem set up, except for we want to do one more thing. And that is bring the decimal straight up from the new location into the quotient. Okay, so now we've placed the decimal where it belongs, and we're ready to go. let's see, sorry. Start dividing. Add zeros as necessary, and we'll go through that. And then what we'll end up with is either this original problem will either terminate, so no remainder, terminate, so put that in red, or repeat. Okay, so those are ours. And remember, when you have a repeating decimal, you write the number of digits that repeat once and put a repeating bar over them. Alright, so time to do some practice. Directions are going to say divide. And then it's going to say round answers to the nearest hundredth. Now, the second piece of information basically only gets followed if I have a decimal. If I have a fraction, I don't need to deal with it. But if I have a decimal, that means I'm going to have to divide one column past the hundredths, which would be the thousandths, because that digit's going to tell me how to do the rounding. Alright, so let's start off with some easy ones. So again, original problem equals answer is the minimum I should see. So on negative 16 divided by 8, signs are different, answer is negative. 16 divided by 8 is 2. So that's the answer is negative 2. Alright, what if they write the problem horizontally? And again, the only reason why they write problems horizontally is because they can fit more problems on the page. So I have same signs, so my answer is going to be positive, and 63 divided by 7 is a positive 9. Done. Okay. What if we have a fraction problem and we have negative 5/9 divided by negative 5/6? And remember, these parentheses are just to make sure that the sign gets attached to the value. Okay, so job 1 is to rewrite this problem as a multiplication problem. So we keep, change, so division became multiplication, flip. And notice that what I do is I keep the sign on the numerator. Okay, we go ahead and we look for any cross-canceling. 5 goes into itself once and into itself once. And 3 goes into 6 twice, and 3 goes into 9 3 times. Last, we multiply straight across. So we look, same signs, positive answer, 1 times 2 is 2, 3 times 1 is 3. Actually, let me erase that and make that red. So, 1 times 2, 3 times 1. Okay, let's do another one. And vital that you understand this problem, because it's going to show up on your test. Sometimes they write their fraction problems vertically, and it looks a little confusing. So what you need to do is look for the fraction bar that's longer, and that's going to help you separate these. So this is really 1/3 divided by 8. Now remember, any whole number can be rewritten as a rational number, a ratio of two integers, by simply giving it a denominator of 1. Okay? And then we look for keep, change, flip. So we're multiplying by the reciprocal. And what we end up getting is there's no cross-canceling whatsoever in this problem. So we multiply straight across. 1 times 1 is 1. 3 times 8 is 24. And there's the answer. So let's do division with decimals for a change, huh? So we've got 2.5 over 12. So again, we need to remember this actually is read as 2.5 divided by 12. So the question is, do I need to move the decimal point in the divisor over? And the answer is no, because there's no decimal in the divisor. But what I can do is bring the decimal point, I'm going to try that again, straight up into the answer. Okay? Now then I start dividing as if the decimal's not there, and 12 goes into 25 twice, which is 24. Bring down a 0. I cannot divide 12 into 10, so I put a 0 into the quotient before I can bring down another 0. And then 12 goes into 100. Let's see, 9 would take me to 108. So 8 would take me to 96. And the difference would be 4. Now, remember what the direction said. When I'm dealing with decimal answers, I'm going to round to the nearest hundredth. So this is the column I'm rounding to. He's going to tell me what to do. 8 is over. 5 or over is my key number I'm looking for. It's that. So that's going to take that answer and round it to 0.21. So the 0 becomes a 1 because of the 8 helping it to do that. Alright, let's see. Where can I fit in? I'm going to try to fit in number 6 here. This one is going to be written in the old-fashioned horizontal style. So 3.45 divided by 1.5. So remember what this says is 3.45 divided by 1.5. So what we do is we move the decimal point once over. So now that becomes 15, but I need to move it over once over. So now we have 34.5. I bring my decimal point up into my new spot, and then I start dividing. 15 goes into 34 twice, which is 30, with 4 left over. Bring down the 5. As long as my difference is smaller than my dividend or my divisor, I'm good. 15 goes into 45 3 times. Ooh, boy, that doesn't look right, does it? Let's move this guy, and we'll put him over here. Okay, and 15 times 3 is 45, and I have no remainder. So my answer terminated at 2.3. Now, notice that in number 5, I don't know if my decimal is going to repeat or not. All I know is I had to stop because the direction told me when to stop. Okay? All right, good luck on your homework.